everyone, and thank you to the NUE's presentation on military applications with the NUE Energy product. We're very excited to teach you guys a little bit about the applications here at NUE with mobile power options in the military applications. And we are excited to have all of our guest speakers here. I'd like to introduce Paul Schmodaloka, who is the CEO of NUE Energy. Myself, I'm John Weber. I am the VP of Sales. And Lita, who is our International Business Development as well. So if you guys are interested in contacting NUE Energy, please take note of these email addresses. We do also have a very special guest from JDI Integrations, who is one of our distributors for power electronics into the military realm. And JT has joined us as well. JT, would you like to say hello?
Yeah. Thank you, John. I appreciate it. So hello, everybody that's out there. I don't want to jump ahead right now, but take a moment quick to say hi. And thank you guys, NUE Energy team, for inviting us and JDI to be a part of this today. So I think that is just another thing that is reaffirming the relationship that we're building together. So looking forward to the discussions though today.
Awesome.
And I'd like to just highlight a little bit about backgrounds. Myself, a former captain, US Army, served in artillery and special operations, focusing mostly on hearts and minds and counterinsurgency. JT is a former recent special operator, which is why we're not putting him on screen. And Lita is a renowned biomedical engineer, extremely connected in Ukraine, in both the medical side as well as the military side, and responsible for a lot of the missions that we've been fulfilling, surprisingly, over the last 2 years.
For myself, I've been in the solar industry for going on almost 15 years with a variety of applications, done a lot of international installs and applications throughout the world. And here in the United States, it's been a really exciting time at NUE Energy, quite a different change from the traditional residential or commercial solar, seeing how we can bring portable power. Really, your imagination with portable power is the only limitation. So we want to encourage you guys all during this time, think about all the little nooks and crannies where power can be used, where you've had situations where you haven't been able to deploy or use equipment because you just haven't had access or easy access to power, and we're a great generator alternative. So I'd like to introduce our product line. The NUE Energy is a portable unit. So this is essentially a Pelican style case at 3.6 kW inverter or 2.5 kilowatt hours, 5 kilowatt hours with a 3.6 kW inverter. We also have a smaller unit that's a 2.5 kW inverter with 2.5 kilowatt hours of storage. And what that allows you to do is choose the weight more than the application, and essentially your endurance or your runtime. What we'll be covering today is how we can help power the warfighting wherever you go. And it's not just about those forward operating bases or things like that. We'll be covering how we can do things at base applications with increased security. Sometimes it's just about being able to put a light out on a corner of a base that you've never been able to do. And ultimately, our goal is to teach about how we can reduce fuel consumption and that fuel abatement, reduce logistics costs, and be able to increase the endurance of our warfighters in whatever scenario that they're trying to do. We're also seeing a lot of high-powered products of the past getting smaller and smaller, and with new chipsets and new designs, we're seeing something that would have required a vehicle to power is now getting down into something that's man-portable and very, very small, both on the military side as well as the medical side. We have had some partners we'll talk about a little bit later who now have a portable X-ray machine that can be brought out into the field. So if somebody has a broken bone, a medic can look at it right then and there and make an assessment on how quickly it is. And if you looked back 50 years ago, an X-ray machine would have filled a room. So those are some of the great things that we're doing, and being able to match our technology as technology changes. Of course, Paul is a first generation Ukrainian, and we've seen a lot of effort over in Ukraine with our equipment supplying for hospitals as well as forward operating bases. And just in general, with the hurricanes and other disasters that have unfortunately hit the US, as well as around the world, disaster relief is also a special part for different groups in the military, be it the National Guard helping out and deploying with power, or even international, sort of that hearts and minds thing of being able to bring power to where they need it. Paul, I'll let you take the next slide here and talk a little bit more about what's happening over in Ukraine. And if Lita wants to jump in, please do so as well.
So we've been active in Ukraine since February 25th, 2022. On the military side, we're going to show you kind of how we evolved into it. But basically, we work along all that white-orange border, including we even have units in the Kursk area. In the photos, you just see some representation of some of the missions. Obviously, drones, special operations, that's the Kraken unit down on the right, but also critical infrastructure, which is a part of the hearts and minds of managing any war. So yeah, I just wanted to bring up that is a lot of how we started, but we've been evolving rapidly. We've done several projects with JDI in Africa, and also now evolving in the US space.
Thank you.
But a lot of the lessons learned are, for example, from this, which is an early project of ours where we were powering an Excalibur targeting system, a Starlink, and repowering the tablets for a 155 millimeter artillery battery. And this was along the Kherson front. This is something that Lita put together.
Excellent.
Let's keep moving.
One of the things that we're seeing on the new battlefield, especially in Ukraine, and if you've spent any time watching any of the videos, they're readily available, you can see how quickly technology has changed, in particular with deployment of drones and thermal drones for pennies on the dollar compared to what would have been available to militaries or even insurgent groups going back 15 years ago. The modern warfare, we're definitely seeing huge changes. One of the main changes that we're seeing is that reliance on more and more power. The old saying, or I guess it's a new saying, is, watts are just as important as bullets. When we look at the total theater, basically information is just as important as a bomb or as a bullet. And unfortunately, we are seeing that infrastructure like generators are at extreme risk because, again, we mentioned those thermal drones. A small generator puttering about behind a building is an easy target. And you can see here where they actually lost a generator due to a direct attack from a drone. So what we're being able to offer is something that is thermally quiet, acoustically quiet, and doesn't require fuel because we can deploy with a solar panel to recharge that unit. So we definitely bring that supplied power into the building instead of having to leave it outside. And really what we're seeing on the larger side is we are being able to bring our equipment into places that traditional off-the-shelf equipment just isn't surviving. Some of the first equipment deployed was the usual stuff that you can find off of Amazon and whatnot. And those units were getting banged around. The plastic was shattering, the screens were getting destroyed because they just weren't made from the right materials and they just didn't survive. So with our wind and rain resistant cases, we're able to bring that product into the trenches, as well as those forward operating bases that we see in Ukraine. And we hope that this sparks some of your own thoughts about how you guys could use power when you really need a tough external case, and being able to bring power where a generator just didn't make sense before, and you need that endurance.
Yeah, and I would just add that we're evolving. We have brought various equipment to play in Ukraine based on funding available and sizes they needed. We've learned a lot of lessons. So not everything we've done to date has been perfect, but going forward, we've mapped all of that into our latest approaches in the field and latest products. So there's a lot of learnings.
Yes. So New US Energy does build a professional grade, easily deployed unit. You can see here on the left-hand side an example of one of our units. Down below is the solar panels, and this is a marine grade panel that we've applied round 5.56 rounds to, and there's a very high survivability of those units. The other thing is that depending on the configuration, there's a really good chance that you can actually skip a panel and keep that unit going. So instead of the traditional panels where one thing damages one thing and the whole system goes down, there's already redundancy built within that panel itself that should some damage occur to part of the panel, you can still reconfigure it very, very quickly. Literally a flathead screwdriver or a small knife is all that's needed to unclip the clips, and then you reconfigure it to keep that system going. So it is has some redundancy already built into it. What's nice about these units, and most of the loads that we are going to talk about and we see these units being used for, are in the 15 to 20 watt range. Maybe a drone's going to consume more than that, but we're talking about small loads relative to the amount of stored energy that we'll be able to supply. So that's going to give you days or even perhaps a week of endurance on standard things like a laptop or like a small Starlink or Wi-Fi system. These types of products are a great match to what we can do because we can help build that infrastructure up. And that applies not only to the military, but the medical and the disaster side.
The other thing that we're working on is to build in field adaptability. So just some of the lessons we learned is, operating the field, they need to recharge these as fast as possible. We've learned from the Israeli Defense Forces, they're actually cannibalizing battery power that's in abandoned cars in locations where they're moved into and recharging small battery devices. In Ukraine, sometimes they use solar, but people brought in glass panels early on and created targets, and so soured certain commanders on recharging in solar. And obviously, you can see here there's no reflections and no glass or aluminum frames. But recharging often takes place where they have to bring the unit back 20, 30, 40 kilometers where there is a generator that can operate safely beyond drone range, and they have to recharge as fast as possible. So like we've been tripling the speeds of our recharging as a result because they want to get the unit back and operating. The same goes for solar. If you can put more solar on it in a field expedient situation, the quicker you can put the panels away.
Yeah, and to Paul's point, that robust charging source is 1600 watts. So if we do a little bit of quick math, that means our larger unit with a 5 kilowatt hour battery can charge from a robust source, a 15 amp source, in 2.5 hours. You can refill that unit. And our smaller unit, that 2.5 kilowatt hour battery, it's the same size charger at 1600 watts. Again, we can get that unit charged up in about 90 minutes. So this is about getting something turned around. So if somebody is field deployed, they can come back in an active operation, get a charge going on that unit, resupply themselves, and likely in those 90 minutes, they can be ready to go back out into the field. Let's spend just a quick moment talking through what's available on the units themselves. It does have a 12-volt aux port, and there are still some use cases there. We have several USB ports peppered around the unit. Oftentimes, we're seeing that charging phones, small tablets, and some drones are even USB charged through a Type-C. Typically, we have two AC outputs, so that's where you're going to plug your laptop's power supply into, or just any universal AC. And a lot of products are really on the AC side. So if you can plug it into the wall, you can plug it into our unit as well. Off the side, we do have a charge controller so that we can add up to 1800 watts. So while we're spending a lot of time talking about sort of that rapid deployment, if somebody's going to be in place kind of behind the lines far enough, you can deploy a significant amount of solar. To put it sort of into Western terms, you can run a tiny home very easily off of this, an RV or trailer. Those type of products or solutions can be easily driven from this unit. We also have natively 48 volts, and I think we'll hear a little bit from JT after a couple of slides of videos that Paul wants to share. Most vehicles are running 48 volts these days. Could you potentially jumpstart a vehicle? Absolutely. Could you charge off of 48 supply? Potentially, and we would talk to you about that application as we're developing further into there. So that's a basic overview of our unit. The larger unit weighs about 130 pounds, so it is definitely a two-man lift. I've hauled it myself in and out of vehicles, and it's just heavy enough to be awkward, while the smaller unit is 70 pounds, and I really am quite excited about that unit because it is one-man portable and pretty easy to get around wherever you need it. So if most of the time you don't need the very large system, you need exactly what you need, and that's why that 2.5 kilowatt hour inverter with 2.5 kilowatts of storage is a great match. Technically it's 2.4 kW, but I'm rounding for succinctness.
She's texting me. I can't.
So Paul, do you want to give a short introduction to this video for us?
Yes, and then we're so this is we call this kind of our first project that we ever did. We didn't know we were going to end up so close to the front line. So it was so new, the technology, that the user called it and dubbed the term the magic box.
В Донецькій області в районі річки Сіверський Донець є у нас в одному батальйоні такий медпункт. Світла і води тут немає вже 3 місяці. Електричний генератор. Панель. Сонячний.
And so this is very close to the front lines as it was moving. And there's the so that was an early unit of ours. And over to the left, you see the insulin supply, small fridge. So this is a part of keeping the population and refugees alive.
За таку штуку. Юра дуже помічна. Дякую.
So that was actually our first military user.
Paul,
John, we have
to say that the lighting that was behind him and even that radio that we see in the screen is all being run off of that box.
on the Starlink.
Yeah, and the Starlink. And you can see some other sort of small ancillary things. What's interesting is if you watch and see some of the videos out there in the current conflict zones, how important small battery packs and keeping cell phones charged is to some of these war fighters that we're seeing in the Middle East as well as in Ukraine. I think JT would probably say that that's a bad idea, but oh, sorry, Paul, it automatically played. Just 1 second here. Do you want
No,
to
it's quite all right. Actually, at this point, we have a important guest speaker who's just requesting. John, would you mind going to slide 20? I'm sorry for the awkwardness, but I wanted her to be able to comment on the military medical applications.
Oh, yes.
As it started with that one experience. So my apologies to everybody for this, but we're dealing with people, some really important guests here. So Lida, are you able, if you could unmute yourself, please, and join the conversation. One back, John. No, one more. Oh, shoot.
Here we go.
Perfect. Lida, over to you, if you could comment.
Thank you. Hi, I'm here. I can't get on video apparently, but that's okay. So here we have some case studies of military medical applications. And as you see, they're challenged for fuel out at the front. And part of that is because of prioritization of the fuel across the front line. And so one comment I wanted to make on that is we're actually keeping these teams safer, the very, valuable medical personnel, these people, obviously every life is important, but their training takes years and years as doctors, anesthesiologists front, to keep them safe by reducing the need for excursions for fuel, which we've heard about. Sometimes they just have to go out from their secret location and just get fuel in a little car. So here we were able to create an autonomy for them. And so we see that we're able to run medical devices and refrigeration, as you see in the lower right, is a scene from that same first forward point. And in the so-called stabilization points of the Ukrainian army, we're also getting very closely involved with the transport and storage of blood and blood products, which need to be refrigerated and are a very life-saving intervention at the front. And so on the left here, we see an earlier version of the Sun kit, the white metal enclosed box you see at a military field hospital. And they were so thrilled. They made a video with rock and roll music, and this guy was almost dancing, patting this device on the back with total joy. And then in the middle, Paul, is that one of our,
Yeah.
well, yeah, so that's a blood storage, portable ruggedized blood storage device that we are also working with. And here in the middle is another team that's using both, using our power devices to power medical devices on board certain kinds of vehicles that they run around in to keep their warriors safe and to be ready to intervene medically as needed.
Lita, do you have a sense of before and after how often they're having to go get fuel now compared to before?
Well, the other issue is that these locations close, change and close a lot and move forward and back with the front as needed. And sometimes those are not very large distances, but that can change their access. And so that's just one anecdote that I have in terms of one of the locations we've worked with. And wow, we don't have to run around with jerry cans for fuel anymore. I think that one of the bigger interventions that they've seen that has been effective is the provision of blood, and they're so happy that they can create an autonomously powered zone in which they can secure this blood supply and also communications, which is so critical for all their operations.
Great.
And if we move that story off of the front line and we start talking about just damaged infrastructure and civilian help and power, would you mind commenting a little bit about just the hospitals that are many, many kilometers behind the front line, but because of damage to infrastructure, what's been the consequences and how's the NUE solution helped to apply?
Absolutely. Well, we find that many of the hospitals are damaged in parts, and those are the ones that have actually, been at the most dire need for reserve power like this so that they continue their operations. But we see that it can also happen to any of them. And so as we engage with larger health systems to discuss their needs, and they have now also come to see that the need is there for reserve power that's reliable. The consequences of also saving on fuel costs have been substantial for the municipalities that run these health systems. They were previously running around with their cars, bringing fuel to different generators, or certain hospitals or institutions did not have a budget necessarily with which to fuel the large diesel backup generators they have received.
Yeah, so I would like to encourage the decision makers that are watching this video now or listening to it later, also consider and think about that when we come in as a military operation, infrastructure gets damaged not only at the front lines, but behind there. And one of the challenges that I would give to those decision makers is to think about how, instead of exposing your teams to logistics of delivering fuel to these locations, that providing a renewable energy solution drastically reduces the power, because typically a large generator is not being loaded down to its peak performance. And so one of the things that we do is be able to charge quickly and get that generator turned off. And so from the front lines to just civilian life behind the front lines, being able to reduce those logistics issues by being able to provide this type of portable power is a powerful statement to that foresight of knowing that we need to reduce logistics and be able to supply power in a more thoughtful way.
So yeah, we're going to go into more of the tech stuff in a second here. And John, so we're just going to show you guys a summary of a lot of the missions. So there's subtitling on here. Go ahead and run it, John. I can edit. And then we're going to talk to JT a bit. So you've seen some of these photos. But drone recon teams, this was a real mission, but in the first person view, drone environment, command and control. And I'll comment, the size of everybody's requirement changes with the mission. Command and control always wants bigger units. But even in the artillery and the anti-aircraft space, they need comms. They want to run video. They need they actually detect counter battery fire via live video integrated with the recon teams. This is a real mission here that we helped enable in the Kherson region, and this is just a list of a lot of the units that we've worked with in Ukraine specifically. So, John, over to you and JT. And Dustin, if you can, please enable JT's video. Thanks, John. Go ahead.
Or at least to unmute. Yeah, so we have a special guest from JDI. JT has quite a bit of military experience, and we thought it would be very pertinent for him to join us. Instead of looking at a black box, we will go over to, okay. Yep. Hold on a second here. So GT, we had some questions for you. Just can you speak a little bit to your own experience as you've seen the modern warfare changing since when you were in active duty? You're with JDI now, but in active duty, how have you seen things change over the last couple of years? And what is your prediction with the needs for portable power coming to the modern battlefield?
Yeah, not a problem. I think there's a drastic shift happening right now compared to the previous 2 decades, and especially with regards to how various SOLF entities are being utilized on the battlefield. The days of, on and off the X direct action, where in reality the conventional force was more supporting SOLF than they should have been, those days are kind of over as we get more into that near peer, peer-to-peer style conflict, as we prioritize areas like the Southeast Asia, the island chains down there, and the challenges that brings, the Arctic environment, the challenges that brings, and getting back to the SOLF operators actually supporting and enabling the conventional forces. Those mission sets are just drastically different and typically longer duration. And the longer that you are out there in remote environments, the more resources from energy, food, water, ammunition, etc., start to become important. And sustainability on all of those will be directly related to kind of how long you can hang out in the field and conduct your operation. So I think that's the direction we're going across the board right now.
Yeah, so SOF, for those that don't know, is Special Operations Forces. And something that we had talked about is just the time in the field increasing as it becomes sort of, as you said, changing from where traditional forces have opened up corridors for, sorry, it's the other way around. Well, Special Operations Forces are having access opened up through traditional military means. And now we're seeing it kind of reverse, where the soft groups are now opening up for the traditional forces. And so that's a little bit of a flip, but that also means that you guys may be out in the field longer.
Yeah, that's, I mean, that is exactly what special operations were designed and built around initially, was special operations enable the conventional forces because in a traditional conflict where it's more that near peer-to-peer environment, you need mass like ships, aircraft, actual people to win those kinds of wars. So the soft operators would do things like take down the air defense. You know, they'd sneak in, take down the air defense so that your planes can now fly in, etc. The last 2 decades in the Middle East, primarily, that hasn't necessarily been the case because we've had full access to the air, completely uncontested air superiority, and we were going after a lot of single individuals that were known to pose a threat to the US and not a traditional nation's army. So, because of that and that mission profile, you're not taking a helicopter to a house where you know a bad guy lives and then flying back out same night. You're trying to overcome an entire nation's defense system, which usually means you're going much slower and the hard way of sneaking into an area, and then you're going to have to be there for a while to take down the defenses or monitor pattern of life, et cetera, relay the necessary information back to the higher headquarters to enable the larger movement of troops into the area.
And so having a larger storage device or having something that's renewable where you can deploy a panel for a short time to refresh, how does that change the theater of operations or the logistics side for those soft groups?
Think especially with the mission sets that I've kind of touched on a little bit, and there are various other mission sets that all have varying requirements in terms of resources. But with what we've kind of touched on a little bit, um, previously, you know, we would carry in every single individual would have to carry in extra batteries to power things like the radios, the computers. We weren't extremely technology intensive at the time, but nowadays, you're going to be bringing things like small UAS drones as well. But still, each individual would have to carry extra batteries. And then we didn't have a method to recharge. So you kind of had to look at how long you're going to be out there. Like, oh, we're going to be out there for 6 days. Like, okay, well, everyone make sure you throw at least 4 batteries or 3 batteries in your pack. So your entire element is carrying that weight. And when the batteries are done, you're still carrying them. You're not throwing those away. So it really reduces the amount that you can bring with you. And it also, you know, increases the amount of weight you're carrying, et cetera, and it limits how long you can stay out there and do your job before you need to come back. So having the capability, I guess I forgot that part, to actually recharge a battery that has more capacity frees up a lot of people. You know, the 117 Golf batteries, which is the primary satellite radio we used, weighs about 4 pounds each. And, you know, if everyone's carrying, you know, 3 of those, you're carrying a lot of weight in batteries when it's said and done. And then you're still carrying it on the way out because they don't get lighter when you use them. And
Right.
so being able to have just one guy carry a battery that powers the entire station, like your little foxhole, and be able to recharge that, now your limiting factor is not energy, it's probably something like food or water. So yeah.
One final question for you, JT. I'll flip the slide, but I want to keep talking to you because this is the most uninteresting slide, a black square. In the realm of hearts and minds, you know, when we were speaking last night a little bit, we touched on, you know, being able to provide infrastructure not only to the troops, but those that you're interacting with in remote villages, and how they can come back to the same bad guys as before because they are providing some of those things. Would you mind kind of retelling that story or that perspective?
Yeah, not a problem. So we were discussing, and I think you kind of hinted at it a little bit earlier with some of the logistical troubles of fuel, but everyone is getting a lot smarter on what right looks like and what sustainable looks like in these conflicts. And it didn't take too long, probably too long for some, for us to realize that if you conduct operations in an area against an adversary and you win, but you leave that population now in a completely desolate condition, a lot of times these populations are reliant on your adversary for resources. So if we come in and take out the adversary, now they have no one to lean on for resources. And it won't take long before they go crawling back and start facilitating our adversaries again because they need those resources, energy, food, water, basics. And not only that, we have found, I've seen firsthand that trying to get resources to them um, across limited roadways can get very challenging because you may have run an adversary out of a small population, but they can still put checkpoints on roads, and you're not going to get a driver to drive a truck full of gasoline or diesel across the desert when he's just going to get rolled up and never make it there anyway. So it's not that getting a generator is the problem, it's getting fuel. And people know that we're not the only ones. So they set up a checkpoint or they drop a mortar on a road and just eliminate the potential opportunity to even get that there. Now, all of a sudden, this population is struggling with their ability to cook, clean water, etc. And they have no one else to go to but back towards the people you just ran out of there. The ability to kind of put something like this in and make them more sustainable um, would be huge in creating, progress moving forward, a sustainable progress where we build our allies further and further and kind of overcome that mentality of, oh, the US is just going to leave us anyway. So stuff like this definitely extremely influential and helps to shift the mindset of the locals in these areas where the fight is happening.
And I would highlight, having done some of this in Central America, ease of use of the technology is critical. You have to be able to it has to be intuitive, and they have to be able to just press a couple of buttons and connect the panel and have it work. Can't be too complicated.
Even to the uninitiated and post-hurricane that we've seen this year in 2024, helping out in the Carolinas with an NGO we have there, we've seen a little bit of a learning curve as people who have never really interacted with small portable power get used to it. And I'd like to say that we've had a very, very high success rate with the uninitiated being able to use our products and use them successfully. So that simplicity of these modern products is just as important as what's inside of them, is how to get what's inside of them out and doing the work that we're looking to do, both in disaster relief or the military. Paul,
John, in the
would you like to
interest of
speak to
time,
this?
maybe,
Go ahead.
yeah, maybe, John, maybe you can just go quickly through the next two and then move to engage Jordan a little on some of the new power needs, the technology wise. Just cognizant of time.
Yes. So Paul, if you want to speak to this high mobility, and then we'll talk a little
Yeah,
bit.
no, I think we have already. Let's just move on.
Thank you. So we keep speaking to this idea that when you run out of gas, you run out of power. And really what we want to impress upon everyone is that we're not talking about getting rid of gas generators altogether. We're talking about being able to use that energy and that supply in a very, very smart way. So here on the right-hand side, we've got a Viasat satellite communications device, a NUE Energy 2025, and a trifold solar panel system. This was drawing about 130 watts. And what's interesting is this panel was producing about 180 to 185 watts, which means not only were we completely able to run the satellite as well as the Wi-Fi signal to get that out and spread it out through the hangar that this unit was sitting outside of, we're actually charging the battery as well. And we could have actually run a laptop off of the same amount of power without taking anything out. So when we look at how we combine our product not only with renewable energy here, but also along with the generator. It can complement that system. So if you need to rapidly charge, you fire the generator up, you get it charged, and you get it back out into the field very, very quickly. If it's a slow burn, meaning that we have something that's going to be deployed for a great deal of time, like a satellite communication, throwing out a solar panel, instead of consuming a couple of gallons or a gallon an hour off of a small generator, with this style of system, we could use that same gallon to charge this unit up, and then be able to run the satellite system for most of a day. So it's a smarter way to use the power. And then, of course, if we're able to then add solar panels to it, while we can put a very much larger solar array on this unit, this is a rapidly deployable product that you can see here, where we can just roll it out, plug it in, and then provide for the loads. And within just a couple of minutes, we just reverse the process of unplugging things, fold that panel up, and get it onto the next location. So this is a very fast and rapidly deployed system, uses fuel in a much, much smarter way. And especially with those tiny little loads like a Viasat or any sort of satellite communication, it is a fairly small load, and it is arguably a waste of fuel to not have that generator loaded down to peak performance. So this is rapidly deployable logistics product that can be deployed in the front lines as well as in the rear also.
And the panels will create they will create a heat signature, but it is not the same as a glass panel. And they're a lot harder to detect depending on how you place it. Just a quick one. Obviously, there's a lot of new tech. Lita commented on the portable medical technology, which, is not only military, but also driven a lot by the civilian field. But let's move on to the next slide, John, and get into some specifics. And I'd love to have JT comment. But we worked a lot with these drone teams, and JT commented on mission extension. We have a great case study where our Ukraine team worked with a recon team in a clandestine vehicle, extending their mission from 2 to 5 days was the goal that we achieved. So, and we actually, they used the panels effectively. They did store them inside the vehicle and deployed where it was tactically viable. So next slide.
So within the
I'd just like to comment briefly. The FPV ecosystem is something that's evolved strongest in Ukraine, and JT, this is one of these things you said it, when things change fast. Boy, this has been an area where it's changed fast, and it's come upon us, and it changes regularly. There's more that we would have fit into here onto the slide. It's just not always easy to fit it, but obviously the battery recharging, and then the command and control, being able to power up those screens and see what the first person operator is seeing. There's goggle recharging. There's a lot of tablets being recharged. There's always a Starlink linking this back up to HQ. But the other thing is they do have to often run directional antennas, because these small drones they have a rather limited range, and if you lose connectivity, you lose basically the drone mission. So there's just a lot that goes in here. And then what's missing from this as well is electronic warfare, in that often these teams will have a REB, or a electronic warfare jamming device, that they need to power as well. So John's got a photo of it here. But, JT, I'd love to hear some feedback from you in terms of complexity. I mean, what you think if you were going out on a mission, now, let's say against the Houthis, and they have drones, they're launching drones against shipping. They're not a sophisticated, organized, military, but their capabilities have been dramatically enhanced. I mean, how does your fear factor change? I mean, how do you approach things differently, do you think?
Yeah, a very challenging problem, as I think everyone is able to observe with everything going on in Ukraine, because especially you mentioned the Houthis. I mean, you go places that aren't a designated area of armed conflict, where there is a civilian populace that is able to freely move and probably very close to your location. Uh, we are seeing that it takes someone a couple minutes maybe to stop a truck and launch a tiny little drone and go over your HESCO barrier or wherever you're located, because those kinds of environments, it's hard to tell who's the bad guy and who's not. And if you further that, so the electronic warfare stuff that you mentioned is becoming increasingly more important, not only for hardened like infrastructures, but also portable options, backpacks, vehicles, etc. Um, yeah, because you don't know who is going to just pull one of these out, launch it real quick, and if you're going to have even enough time to take it down. These small FPV drones are flying, over 200 miles an hour. They're crazy fast. So if that person's already within a few hundred meters, you really need to be on your A game. So the complexity is just rapidly increasing, from because it's hard for an operator to address their warfighting skills and now also be tasked with, by the way, you have to learn all these new things with electronic sensors. And because of this new increasing threat, you're just attacking on more and more. But I don't know if that answered your question
No, no,
100%.
it's good. And I want to segue into looking at the photo third from left. Uh, you know, what we're seeing in Ukraine often is the need to create a bubble now. And I think it's something I've learned from several of the exercises that we've been involved with and the US military side. And all of that, of course, needs power. And, the question is, do you have the time to turn the bubble on when a threat's detected, or do you have to keep it operating at all times? But, when we see in these sci-fi movies, the shields, right now in Ukraine, the reality is you need a shield. It just is invisible. And all of that consumes, electricity. And then when you mentioned the point about sensors and listening devices, I wanted to share what I learned at the most recent AUSA, the Association of US Army show last week, where we were in booths of several companies that were running these aggregation systems. So the two photos on the left aggregate amazing amount of battlefield data. They're portable, and they're connecting, for example, with the sensors that can even sense the vibrations of a tank and designate the model of that tank. Okay, so it'll be like T-72 or T-80. So there's just and those who can process this information and synthesize it effectively are the ones who gain the edge. And so these all, of course, as you can see, elementary to us, is they all require power. And it's like, so how long can you be out on the mission if this unit here is autonomous for 6 hours? You're just gonna have, how many 6 hour missions? You're definitely gonna have certain ones, but not in a recon environment. You got to have, JT, like you said, you've got, when you had I think you were saying yesterday in our preparation, you had, your quick missions, but then when you're in the recon mode, they're long missions.
Yeah, they definitely are. And then something you kind of hinted at, I think, earlier was with the generators, and it kind of fits in here is uh, not just the heat signature of the generators, but the mobility requirement, because also the radio frequency broadcast of these UAS teams. They are quickly being triangulated and located, so they can't stay in the same place for a prolonged period of time, which means that their energy sources that they need to operate and do their job have to be able to move with them, especially if they're bringing additional equipment like the sensors you have on a screen here. Um, you can't be in a hardened structure, even if you didn't use a generator. Even with your units, Paul, like right now, they still have to be able to pack it up and move very quickly
Yep.
because they will be located. I know drone operators right now are like snipers were in Vietnam. That's what everyone is going for. So the portability factor is massive on top of that, what we already talked, the ability to recharge and extended duration.
Yeah, and that's why we're building right now man portable, units, and so and trying to put as much energy we can into, versus weight and size. So John, let's move on real quick, just because we can go through quickly
Yeah, if I may add
some of the
one other
remaining.
thing, just for the audience benefit to understand sort of time versus consumption. This unit here, the spec sheet says that it's 130 watt loads. What does that mean? That means that we can run, it comes with a battery that lasts for 2 hours at that 130 watt load. With our unit, the 2425, we could actually run that unit continuously for 18 hours. So if you're jamming at specific times when you're on movement or whatnot, suddenly this could turn into a week or 2 weeks worth of use with the availability of the power that we're providing. So just kind of giving a relative point to consumption. Paul, go ahead.
Yeah, no, just I'm going to go through very, very quickly, but this is the modern tactical operating environment in Ukraine, where they're pulling in drone data from just tens, if not, hundreds of drones at one time. So you need that. You got more computers deployed forward, more monitors, because you can't process all that information on a small screen. Commanders have to be able to step back and make decisions. And I will comment, the threat is real. We sadly have lost users of ours, not particularly linked to our equipment, but they were killed by first person drones. We had a unit of ours blown up in the Bakhmut area when drones detected one of the teams that had one of our units. They hightailed it out of the building, thankfully, and they survived, but our equipment didn't. So this is a very real thing for us. Next slide.
So one of the organizations here in the Southwest called Southwest MAC invited us to join the Vanguard 2024 experiment at Fort Washuka. It was a very eye-opening event. We worked not only with the teams actually doing the experiments, and one of the main pain points that they had was not everybody came prepared with the right paperwork for bringing a generator out onto the field. And so Southwest MAC and we worked with one of the groups that's there at Fort Washuka to have some rental units available so that when they took them out to the field, they had something that didn't have the same environmental impact as a potential diesel or gasoline spill, and made it very, very easy for them. We saw a lot of really, really great products out there using smaller amounts of power. If you're a base commander or you're somebody in charge of logistics, and this is just not even in any theater of war, it's just the basics of it. With our portable systems, we do a lot of lighting for the film industry and things like that. And so if you need to light up an old building from World War II and it just doesn't make sense to have a generator out there, but some low-cost LED lighting to be put in with a couple of solar panels out the back, and you can put it away when you're done because it is all man portable. There's some really interesting ways that you can bring power to old buildings. In this case, we had a hangar that just didn't have enough plugs or supplied power to run some of the examples that the other companies had there. In particular, learning has become a video game, if you will, with VR headsets and high-end gaming computers, which consume quite a bit of power. They would not have been able to show what they had or been able to provide the training that they did at the base without the use of our equipment. And so we were running 6 computers with 6 sets of goggles for about 3 hours at a time, and we were just rotating 2 units. One was charging and one was running the system. And so we just had to rotate once a day at lunchtime to get them up. So think about that as a base commander or just on the basics of if you have a tent and you need to provide training, and modern training is now being done more with computers than with paper. This is a great way to ensure that training is going to get done and that you're not, again, leaning on the logistics of fuel to deliver and get those up and going. So that's kind of what I have to say about that and just the power, the technology that's available continues to shrink smaller and smaller. And typically that also means that the power consumption goes down. So we're seeing some really neat technologies out there that are only consuming a couple of watts, but they do need to be able to charge them, or even the listening stations from those devices that are deployed is also a piece of critical infrastructure that can now be run for days with our equipment, rather than running a generator where you're having to pour fuel into it at least once a day to keep that up and going. Because again, we're using the available energy as efficiently as possible.
Just a fascinating case study, added power to vehicles that did not have it. This is a 60 to 70-year-old M113. We turned it into a tactical operating center by adding portable power to it. Next slide. We
Lita
went through
covered
this already?
one pretty well, so we'll keep moving forward. Thank you, Lita, for your time. Paul, a little bit about
Right, we've talked a lot about this.
Yeah.
Sorry, go ahead, John. I just will comment, actually JT brought this up about in a really good way. We work a lot in the community resilience side, but he mentioned the issue of, you eliminate the enemy and people still need water, power, food. So this is a critical element. In the other element is when you're in the defensive, and that is you don't want to depopulate an area. In Ukraine, you have the situation where Russia is trying to depopulate frontline areas and the country in general. And so that is an essential element of hearts and minds linked to the eventual, political goals of winning a war. So we just wanted to comment on that. Next. And then, of course, along with that is protecting or enabling critical civilian infrastructure. A lot of them require a lot of power. This is actually a water powering station. They had a generator, but it was unable to run their control systems and communications. So we did deploy there a solar generator. It's really close to the Russian lines, but it is feeding a city formerly of 300,000, which currently has probably 40,000 residents left. So this is just another element to, and JT, you could probably see this in the rebuilding phase. So if we know when we went into Iraq and afterwards, second time around, when we, there was a lot of power infrastructure that was disabled. It is a challenge to manage every single one of those gas generators. And so there is often the opportunity, if the loads permit and the sizes and portability. This is a 10 kilowatt hour unit that we actually manufacture in Ukraine, and the ability to this runs basically autonomously 24/7.
Yeah. Paul, if you wouldn't mind taking a moment, because I'm not seeing where that resource is. If people are interested in helping out on the civilian side with providing equipment for the hospitals, and we have lots of stories of babies being born and surgeries being done, oxygen concentrators, dialysis machines, and even refrigeration for critical medicines. What's a great start for someone who's interested in supporting the...
So I put it in the chat, Google Power Up Ukraine. GoFundMe, and you'll get the link to their GoFundMe. This is associated with Rotary International, and we actually have a major fundraiser coming up in November, but that'll get you right to the link. I'll even do it for you in a second here. I actually donated a couple of days ago as well. The other one could be footprintproject.org has a section on that on their website as well. So I did put in the GoFundMe for that, and I'll try to do the same. Thank you for us. The other one is for military applications. We work with, or for military donations, we work with Ukrainian American veterans, of which I am a member, Post 42. And you can just email me directly and I'll put my email into the chat. And they don't actually do the online donation, so we'll point you to Jerry from Post 42 who handles that. They're a great resource. We've done a lot of these case studies came from Ukrainian American veterans, which is an amazing organization. A lot of Vietnam era veterans.
And if for some reason you're struggling to figure that out, please feel free to reach out to us. We can definitely connect you with the right people if you're interested in helping out. I do want to thank everybody for your guys' time here today. This was just a brief overview about how we can bring power to the modern warfighter, as well as thinking outside the box on where we can reduce heavy lifting logistics and bring power exactly where it's needed, watt for watt. If you are in the military applications, Mike can be reached out at JDI to help connect you guys within the JDI organization. I want to personally thank JT for his time today and providing some real world insight from US Fighting Forces on his previous experience, and excited to continue working with him through JDI. And Lita, it's always lovely to hear your voice. Thank you for joining us and speaking to the medical side of things. And Paul, as always, it's been a great time here talking about our applications and how we can bring power. And again, I'm John Weber with US Energy, and we really want to thank you for your time today. And feel free to reach out to us if you have any other questions. We can open it up if there are any questions from the group. If you want to just put that into the chat, that would be the best place to do it. And we'll just leave the line open here for another minute or so. If questions start coming in, we'll continue until the questions run out.
I think one of the questions that came up is, are we going to have we're going to post this, so it will be on our YouTube channel. Please do subscribe to our YouTube channel. And then we do plan to do a cut of it as well. We realize this has been a lot of information. I thank everybody for listening so patiently. There was a lot of material to cover, as it is a new subject matter. But again, it'll be posted on our YouTube channel.
Excellent.
Thank you, everybody.
Not seeing any questions come in, but if you do have any, please reach out to us. Sales at US Energy is a great place to start, and we'll make sure that we get the right person connected to you. If you already are convinced and would like to place an order, JDI is a great partner to have product delivered to you for field testing. All of our products are well under the $10,000 mark. So for those decision makers, you can make a snap order and start trying this equipment out. And we'd love to hear your stories and support you on your applications as well. So please reach out to JDI and work with us as well on your application. We'd be happy to help. Thank you guys again so much for your time.
Thank you, John. Thank you, Paul, for inviting me.
Yes.
Pleasure talking with
Thank you,
everyone.
JT.
Thank you, JT. Appreciate it.